Hey friends, welcome back to the channel and to another episode of Research Paper Summary. Today I'll be covering an EMNLP 2020 paper, NER for social media text with semantic augmentation. In this paper, they propose to use semantic augmentation to deal with the data sparsity problem that exists when dealing with social media text. The proposed method was able to achieve strong performance results on 3 benchmark datasets. In this video, I'll first go over the context and contributions of this paper. I will then dive into the proposed neural models with semantic augmentation. And lastly, I will finish up this video by sharing some of the experimental results and analysis. I hope you find this video useful. Let's get to it. If you're new here, my name is Ryan. I'm a PhD student based in London, and on this channel, I mainly share my personal development journey as a student entrepreneur, covering my PhD research in AI, my entrepreneurship journey, as well as different life design topics. If you're a student, entrepreneur, first generation student, or all of the above, consider subscribing. Name entity recognition performs really well in traditional English datasets, but it still performs poorly in social media text for 2 main reasons. First, the model suffers from data sparsity problems since entities are often rarer and more unique in social media text, making it harder for models to generalize. Secondly, social media text often suffers from misspellings, acronyms, and slangs. Overall, the main contribution of the paper is as follows. In order to solve the data sparsity problem, they propose an effective NER model with semantic augmentation and achieve strong performance results in both English and Chinese datasets. Let's now dive deeper into the NER model with semantic augmentation and look at how it works. Here's the overall architecture of the NER model. It looks very complex, but don't worry, let's take it slow and start with the input sentence on the bottom left. For each input token, extract the most similar words of the token based on pre-trained embeddings. For example, with the token Chris, we can extract similar words using pre-trained embeddings such as Steve, Mike, Tim, and Andrew, and etc. The augmentation module will use the attention mechanisms to weight the semantic information of these similar words. Specifically, we use pre-trained embeddings and cosine similarity to extract top M words that are most similar to the input token. For the English embeddings, we use Elmo and Birdcase Large. We then use another embedding matrix to map all extracted words into their corresponding embeddings. Since not all the words are going to be equally useful for predicting the name entity labels, we want to use the attention mechanisms to weight the words based on their contributions to the task. And so, for each word, the augmentation module would assign it a weight. The final augmented semantic representation is then computed by applying the weights to the words. The weighted semantic information is then used to enhance the core model using the gate module. The context encoder here is a 2-layer transformer-based encoder to produce the contextualized embeddings. Depending on the context, the contribution of the augmented semantic information could vary, and so we can use the gate module to aggregate the semantic information to the core NER model appropriately. Specifically, we can use the reset gate to control the information flow and balance the information between the context encoder and the augmentation module. Finally, the output of the gate module is passed on to the CRF decoder to predict labels in the output sequence. Let's now talk about the experimental results. In terms of the dataset, we have the WNUT 16 and 17 and Weibo for the Chinese dataset. For the WNUT 16 and 17, the percentage of unseen entities in the test set with respect to the training set is around 80 to 85%, showcasing the few-shot and zero-shot nature of the dataset. Before we dive into the results, I would like to point out that in order to assess the benefit of attention mechanism in the augmentation module, the paper has established a baseline method of direct summation of semantic information as a comparison. Overall, the paper has introduced 2 modules, the attention-based augmentation module and the gate module. Let's now take a look at how they affect the overall results of the datasets. Here are the results of the overall exploration of the proposed attention-based augmentation module and the gate module. The first thing I would like to point out here is that the direct summation has led to lower performance than the baseline approach of no semantic augmentation and gate module. On the other hand, the attention-based augmentation module has consistently outperformed the baseline model on all datasets. Models with gate module achieve far better performance than without. This tells us that the information from the context encoder and the attentive augmentation module varies, and the model should adjust accordingly depending on the context. Overall, our best performing model outperformed the other baseline models on all datasets, as you can see here. The paper also performed additional analysis. They want to measure the performance of the proposed model on detecting unseen name entities. As you can see on this table, the proposed model has outperformed all the other models across the 3 datasets on this aspect. This can be further illustrated in this figure 3. For the input token Chris, our model put more emphasis on Steve and Jason as these two words have the label person, whereas Anderson and Angel never occur in the dataset, providing no useful information. And that's it for today's video. A quick announcement. Over the last few months, my friends and I have been developing a platform called Xeratin, where we convert non-fiction books into actionable steps so that you can spend less time reading and more time taking actions. On the platform, we have over 150 plus actionable steps from many best-selling books. It would mean the world to us if you can please go on the platform and check it out and let us know what you think. I will link up in the description below. Thank you for watching. I'll see you guys around next time.